Hello students, welcome to EduSil. In this session, we are going to discuss about priority queue. As per the definition, the priority queue is a data structure maintaining set S of elements, each with associate the value called key. What is key? What are the values? We will discuss. Before that, I should say I have collected this information from Corman book, or the book written by Corman and other authors. The name of that book is Introduction to Algorithms. I suggest to all the students kindly read the books first. Okay, whatever the books are the textbooks, kindly read that one. Basically, I'm following two books. One is Corman and there is Eva Tados, or you can say Klenberg or Eva Tados book. Only two books that I'm following. Okay, let us start about the priority queue. So priority queue in other sense it is written also in Corman. Heap applications are based on the priority queue. Basically, whenever we have studied the heap data structure, we are now using the heap concepts while using the priority queue. And why priority queue is important? Because priority queue is a part of data structure, and to get the max immediately, like whenever you're extracting the max element, so it could take a less time because the data structure basically we are for why data structure is used that like we have to structure the data in such a way that whenever we need the data, that should be with the efficient time we'll get it. That's why data structure is important. Otherwise we are not going to read the data structure. Data structure is important for one thing, like if you want to sort it, means increasing order or decreasing order, that time it should be efficient time, means not n or not n square, not log n or anything. Now within the less defined time as expected time, we have to decrease it. That is why we are using. As well as whenever you are searching whether the data is existing or not, while as for the concept like you have read in array, whenever you're searching in a linear search, you know whether that element is existing or not. Like there are n number of indices, you have to find one up to n indices. So from this n indices if you are finding is well and good. If you have not found, like you have to search from 1 to n. The worst time complexity is big of n, the searching of the element. If you have any other idea, like some concept that if you have, while finding it, it will take less than big of n, suppose logarithmic time, that could be well accepted. That is why we are reading data structure. To structure the information or to structure the data, we are reading data structure. It's a part of it. Priority queue, and priority queue is a based on heap implementations. Okay, as per the book it is clearly mentioned. Though I collected the information from the book, it is written as for the max priority queue. It supports there are four functions which we are going to use. One is insert s with x, small x is the element we are going to insert into set S. Basically, in the mathematics, we are saying it a set where it is represented like the elements with a comma we are representing. But in other sense, or you can say in computer science term, we are saying it is array. Okay, so array is a collection of similar data types we are using. That is why we are using the mathematical terms as set here. Okay. Next, which is equivalent to the operation, like we are inserting it, means we are adding it. This functions we are using one. This is our first function. The second function says we are finding the maximum of s, means out of this set which one is maximum, we can find it. Okay, for that also the time complexity is defined. Don't worry about it. We will be just starting it, though it's a detailed lecture video. First we have to concentrate on the contents, what it is written. The second one is maximum of S, returns the element S with the largest key. Though we are focusing on max priority queue, these are the functions. Otherwise, if you're focusing on mean priority queue, that insert would be same, not an issue. Whenever you're finding the minimum, that could be like you're finding the minimum element from the mean heap. Okay. Next, third one is extract max. Extract max means you are trying to find out, or you try to remove. Basically, it is written removes and returns the element S with the largest key. Okay, the key means the basically the elements present within the array. We are saying that one. Okay, whenever we are reading the implementation, that time we will be reading this one. And extract mean will the minimum one we are trying to find out. So this is extract min for mean priority queue. Here it is max priority queue, that's why it is written. And S is the set, or you can say S is the array in computer science form. Increase key means whenever we are going to add an element, okay, so that time whether we will be doing the same of priority, like we will be in the same maxif or not. If it is not maxif, so we have to do the maxif conversions. Suppose the answer would be for our timing, I'm just writing it here. One is there, and better make this as three. Okay, here is 1, here is 2. We know it's a massive. Why? Because parent is greater than the children here. Okay, so if you want to add, you know, if you want to add instead of 2, suppose 1 is added, no need to change it, because the key which is previously it was 2, and the key that you are adding is 1, so it is less than that, so no need to change its place. But if you're adding suppose 4 to it, so previously it is 2, and the key value you're adding is 4 now, so that is why whenever you're inserting it, you have to change it to the max heap, because you are working with the max priority queue. That's the implementation of heap basically. That is why you the 4 will be there and 3 will be here. This is how we will be doing as per the operation. We will be reading it. I have collected the information about the uh, you can say the algorithm also. Okay, so heap maximum, whenever you're finding out the maximum element, the first element as per the Coreman, they started from the array index starting from 1 to n. But in general we are saying the array index could be starting from 0 to n, but here they started from 1 to n. That is why we can say the maximum element when it is finding. So they are focusing on the first element. The first element, though they are focusing, always it is the time complexity. I'm just writing the time complexity is we go for one. Okay. Next is heap extract max. Whenever they are trying to find out the maximum element, so what they are doing here, as per the functions, you just focus on here. The first it is written that A is an array. Okay, next, heap size. If heap size is less than 1, means if array we have taken it is 1, if nothing is there, let us take less than 1 means 0 could be satisfied, minus 1, minus 2 could be satisfied. Okay, so in this case means no such element is exist or no such index could be exist. So in that case it is underflow, means we have not yet started. Okay, this is what it suggests. Then else part, in this else part what we have to do, we have to go for the first one is the maximum. Okay, when we are extracting the maximum, so because we know always the parent will be the highest position, the highest is the root. The whenever you are doing the min heap or max heap, obviously it should satisfy the aim. The root should have the maximum element always. Okay, so what it does, first max one variable they have created. As for this, the first element we kept there, and next what we have done, the element which is the first element, we now shifted the heap size. Okay, the heap size could be might be the total array length. A dot heap size means it is like A of heap size. Okay, like A of I, suppose you are writing, so you can write in that sense. Dot represents that only. Okay, so we just shifted that value to the first one. Next what we have to do, like we have to remove that element, because the last element we can remove. How we can remove the last element will be switched, that as we have already studied in the heap sort. Whenever we're doing the heap sort, the last element will be the first element. We have done the exchange. How? Because the max element we have dedicated as the first element, means the suppose 16 will be the maximum element, and we have set to the max. Now instead of 16, what we have to do, the last element suppose 1, and we have changed that 16 here. So no need to worry about it. The 1 will be removed there, then 1 will be removed. Whenever we have removed it, it was previously 10 elements, the 10 elements will be minus 1 is 9. So then in this case we have to do the max simplify. Max simplify means we have to now work with the conditions. Suppose better I'll do the example which will be more clear enough. 4, then I'm keeping it here 2, then here is 1. Suppose this is what we have to find. That could be our very good representation now. And it's my request, those who are new to this video, kindly watch the heap video. Then you'll know how maxipify will work. Okay. So here the maxipify, it represents the I use the index. Okay. The first index we will be working on to make it maxip, and this A represents the array. Okay, it is array and this is our index. How do we work? First we have to keep the value as the maximum values. For that we know it is a max if, though it is a max if, the root always the maximum. Okay, once we have done it, we kept in a max. Okay, what then we have to do? As per this condition we have to uh, do the changes. What type of changes? Now a of 1, I'm just writing it here, a of 1 is equal to a of heap size. Heap size, it is written heap size, means it could be written like a of heap size is this is 1, 2, 3, 4. These are the indices. Why? If you want to represent it in an array format, it could be seen like 4, then 3, then 2, then 1. Okay, so it is first index, it is second index, it is third, it is fourth index. Okay, what we have to do then? Heap size will be this size. The maximum will be the heap size or array length, you can say. Okay, sometimes we are writing the array length also in the heap size. It could be written as, suppose the array length I'm writing, or you can say it is, as for this example I'm just writing a of here I'm writing, it could be better, it is a of array size is 4. Okay, and here a of 1. Okay, I think it could not be visible. I have to just change it, the locations now, because the video is running. So that's why. As per this fourth line, okay, as per the fourth line, a of 1 is equal to a of a dot heap size. That heap size represents this one because the last one array length. So in this case, a of 1 will be a of 4. That a of heap size means the last of this element we have to pick. Next, what it has to, like, a1 is previously 4. 4 is not there because assignment operator, when we are writing assignment operator like a equal to 5 means the 5 value will be given to a. So then you can say it is kind of exchange we are doing. Exchange, this is clearly mentioned in the heap video, detailed heap video. You just watch that one. I'm just changing the color of the exchange. Once it is done, the next could be 1, and here it is 3, here it is 2. Okay, so next step, once the exchange has been completed, then it will look like this, and here it is 1. As per this maxipify, we will do the maxipify, but as per this line, we have to remove it. We have to remove. It means heap size equal to heap size minus 1 means it was previously it was 4, and that 4 will be converted to 3 now. 3 means 1, 2, 3 only. So that is what the deletion condition. Okay, this is what the deletion. Okay, so after that one, whenever you have completely worked in this maxipify condition, now the maxipify we will work on this first index. That is why it is written the array with the starting from one index. Why? Because this is not maxif. Maxif will be the parent will be on the top, means the root or the parent will be for highest than the two children. Okay, or child nodes, you can say. So in this way we can work, like 3 will be converted, 3 will be exchanged with 1, because 1 is less than both of these 2 and 3, and we will exchange the parent, whenever it's a greater than the others, the greatest element will be swapped. So here the greatest will be 3 now as compared to this 2 and 3. That is why we can say 3 will be on the top and 1 will be at their position, 2 is there in position. So this is what we can find it, but this is we cannot say the 3 is the maximum. Why? Because here the return max will be the 4 as per the example. Why? Because we have already given max as 4 now. The max is 4, max will be given as a answer. But again, if you want to run this one, so then the maximum will be 3 as per this algorithm if you run it. So the total time complexity I must write in different color. Okay, because color, all types of color that we have already used, the time complexity now it would be like we are working on the height of it. Though we are working on the height of it, better we can say the time complexity is big of log n base 2. Base 2, why? Because the number of children we are working on are 2. Why? Because it is a almost complete binary tree or complete binary tree. Binary tree it represents means maximum 2 children we can expect. That is why it is written like this. Though it is working on height, so I must write it is because of height. The time complexity we can expect based on the height. Okay. So I hope it is understood by you. Two different algorithms now we discussed, and this third example could be the expected one, which is a proper application. We can say that I'm using red. Yeah, quite a tricky one. It's not easy to understand directly if you are just reading from the book. So it represents the first is the array. This one is the index. Okay, I'm just writing it index, and this is the key value, or you can say element. Okay, any element. This is an array. Now what we have to do here, as per the example, I have collected this example from Corman again. Okay, this example is there in Corman. Let me check the book. It is there in front of me. It's figure number 6.25. It's figure number 6.5. Maybe you can check that one. In figure 6.5, yeah, 6.5. There it is written. So what it has to be done, like what type of question is being asked in exam in general. Run the heap increase key where the index will be like here the index is 1 2 3 4 5 6 7, this is 8, this is 9, this is 10. Okay, as per the index I'm just saying you, these are the indices or index you can say. Question could be run the heap increase key where array is there, and on ninth place the key you are going to insert, heap insert key, I'm just writing in short, heap insert key, array is given as a, uh, index would be 9 and key would be 15. Suppose key would be 15, or you can say key suppose 1 is given. Clear? In that case, what you have to do, first you go for maxify, because as per the book it is clearly mentioned you are working on the maxify. That's why increase key, otherwise other could be different answer we can expect. Now if key is less than a of I, a of I is, this is I, clear, and this is our key, this is our array. First we'll discuss how it is running, then we'll discuss about the time complexity. Okay, it is our ninth index. As for the ninth index, what we have to do is whether key, the previous key which is 4, this is our key now. I'm just writing it key. Previously what the key is, if condition is written, 4 is less than a of I. Sorry, key is, key, what is key? Key is 1. Sorry, here it is key because whenever we are adding it, the key is already given to us, and this is our rth index, but you can consider it key, but right now you just focus on the key is given as 1, and here the index you have to first check it whether it exists or not. So a of I, again I'm just writing if condition 1, then a of I is 4, this is a of I now. A of I means A of 9. Why A of 9 I am writing? Because here the ninth index we are working on, the ninth index and key we are going to insert is this one. When we are inserting, then we will increase the key or decrease the key, that we will be deciding, but first we have to insert it. Okay, first we have to insert it. If we are able to insert, then we will do the increment or decrement. So whether it is correct or not. Now a of 9 is 4. The value is written within that. A of 9 is 4. If 1 is less than that, so a new key is smaller than the current key. Current key is 4. A new key is 1. So no need to decrement increment. Simply place that 1, because it is not violating. Instead of 4, you just replace 1, and it is not violating the condition. It's not violating the max if condition or max if property. If else condition will run, like if key could be greater than a of I, in that case what we'll be doing, in that case also we'll discuss. This is there in example, but which we discussed right now, we're keeping 1 as a key. That is not written. That's why we discussed on a broader part, like when we will do the increment or decrement type of thing. Like key will be incremented if the key value is greater than the current value. Though 1 is there, so no need to update it. You can simply place it here. Once you are placing the element or a key there, so no need to change it, because the property it is following. Why? Because 8 is greater than the key which is inserted. Both the side it is following, so no need to worry about anything, because the rest of the things are as it is. If so, I think this is, it is understood by you. Now I'm just removing the concept. Again, what I'm doing, I'm just uh, putting this value as 15, because it is there in an example of 6.5. So in 6.5 they have inserted 15th key as this value. We have to first check 15 is whether it is less than or greater than the current key. Okay, now we have to check 15 is a of 9, a of 9 is 4. Here we found no, it is not correct, it is greater than this. So else will run, else will run. Though else will run, what we have to do, first we have to set the key as this index. This is done, like we will be placing a of 9 equivalent to the key which we got. After that, what we have to do, we have to just go for a of whether the I, okay, I is 9, then we have to check whether the parent is less than this or not. I'm just removing it for a clarity. I'm just changing the value. Okay, yeah. Now what we have to do is, while condition we are running, 9 is greater than 1, and the parent of I is 8. Now 8 is less than 15. Clear? I Then what we have to do, we have to exchange the value. Where to exchange? Here a of 1 will be parent, like we will exchange the value with the parent only. We are not going to exchange with the topmost element. We are just exchange with the immediate parent of it. Why? Because it satisfies the condition. The parent is less than 15. Yes, it is true, and here it is true. And condition means there is a multiplication, you can say. Okay, and means only true will be true, because this is, you have already read in DL also, digital logic. Like and means it's a multiplication operator. If you can focus on the electronics topic, if you're focusing on the mathematics, and means true will be true, then it is true. Anything will expect except this one, like if anywhere you have like, getting false, that will be considered as false. Or in digital logic, you can say 1 into 0 is 0, that we have already read in a mathematics also. Okay, so 1 into 1 is always 1, excluding this it will be false. So this condition has to be satisfied by any means. Once it is done, the parent will be the I value. Now I value was previously it was previously 9. Now it converted, now it exchanged. Here the I value will be 1, 2, then 3. Here is 4, 5, 6, 7, 8, 9, 10. So I value will be 4 now. Now we have to check where 4 is 1, yes or no, or the parent of it 14 is less than 15 or not. Here it is true, here it is true. Then you swap. Where to swap? The immediate parent will be, the immediate parent is this one. So you can go for swapping of the objects or elements, or the key, you can say. You are indirectly increasing the key, means the key means the value is going to top, or it is in a position. Okay, you do not think that the value increase means the I value is increasing. No, it's not about the index. It's about where it is placing, above it, above to it, above to it. That is why we are saying increase key. Okay, next we have to check the I value is 1, 2, 3, 4, 5, 6, 7. Here it is 8, 9, 10. So I value is now 2. Here I value is 2 means we have to first check 2 is greater than 1 and the parent to it is 16 is less than 15 or not. Here it is false, here it is true. Then what we have to do is false. No need to change. We will stop. So when we are doing the operations here, it is within the height, clear, and above one is giving you if condition is there, so big of one, if clear or not, yes or no. That is why we are using if condition as big of one. Other statements are big of one, but while condition, whenever we are running it, this is based on the height. That is why the time complexity, you can say, based on this, the time complexity will be whether I'm writing it here, big of log base to n, because of the height, because of the height you can expect. And here I'm just changing the color somehow, it could be better to understand. For this reason you are getting the height, though we are focusing on height again, that is why we can say the time complexity is big of log n. Now whenever you are running max heap insert, whenever you're inserting any key, so the function will run like this. A stands for the array, key stands for the inserting value of the element whenever you're going to insert. Here definitely if you are inserting it, definitely what you have to do is heap size is adding one, means you have added it. It is added. Minus means it is removed. Where you are adding last position, last position. And the last position you are adding, last position could be from left to right you are doing. Okay, those who are new, kindly watch the heap video, detailed heap video, there you'll get to know how heap is running. So whenever adding it, it will be the last position. And heap size is like the maximum, whatever we are writing, the heap size, the last element we are putting as a minus element, means the lowest value we will not focusing, because maximum we are focusing on. If it is minimum, we are finding a minimum heap insert, that could be infinity. Infinity is actually not existing, is a greater value. Is a greater value which is, suppose up to 10 you are using, like 1 2 3 4 10, it could be 1000. 1000 means is greater than this, that's why we are representing infinite in that case. So once it is done, so heap increase key, recently we discussed the heap increase key, it is array. Okay, and this is your heap size, means you consider that as your index. Okay, and this is as your key which you are going to insert. So for this reason, the time complexity is big of log n base 2. Recently we discussed because of the height. Though these are the conditions, through these conditions you can say the time complexity we can expect, because these are simply the two terms we are using. The time complexity would be big of 1. Why? Because these are the statements. Though these are statements, we can say the it will run for one time, though it is working. No need to write height because already we discussed this thing. So I hope it is clearly understood by you. If any query, you can message below. Thank you for watching. Have a good day.